Right, good morning. I'm Bhuvan for StudyIQ IAS. And over the course of the next 40 minutes, if you have doubts, say in understanding the basic concepts of geography, okay, because today's editorial edge, we will seek to understand in our first part of the discussion about Walker cell circulation and El Nino. So if you have doubts about those basic concepts, okay, stick around. We'll address that. That's our first agenda. Thereafter, number 2, we'll take a look at lightning because, believe it or not, recently in the state of Odisha, 61,000 lightning strikes were observed within, say, a brief spell of time. Okay, so very, very important for us to understand lightning. How is it formed? What are the causes? And insofar as the Indian, our country is concerned, how is it categorized? Is it a natural disaster or not? What is the consequence if it gets categorized as a natural disaster? We'll seek to understand that. And thirdly, ISRO released a photo yesterday, okay? And that photo, well, I'll show you the photo. So you find that it is an anaglyph. So what is an anaglyph? You know, how is it made? What is a stereo photo? What is a red channel and a green channel? We'll seek to understand all of that in the course of the next, say, 30, 40, 50 odd minutes, whatever time it takes. All right. Your neighbor, Bulbul, Coder. Good morning, guys. Let's begin. Okay, we have a lot of work to do this morning. Okay. This is my Instagram handle. If you have any doubts after today's class, this is where you reach out to me. And this is where you find the PDF of the lecture uploaded at noon. This is my Telegram channel. All right. And if you have any particular doubts, if you would like a longer explanation or if you have a longer question, here is my email ID. You can reach out to me here too. Let's look at the questions from yesterday though. Yesterday we discussed TOPS scheme, right? Target Olympic Podium scheme. So that was the whole point of the discussion yesterday. And so where are the next major events to be held? Well, here in this case, Summer Olympics in Paris, Winter Olympics 2026 in Italy, Summer Olympics 2028 in US of A, and Summer Olympics in 2032. We go down south to Australia. So all of the statements here being absolutely correct, right? Let's move forward. Question 2. Which of the above are not included under the top scheme? So what you find is that there are 12 sports or 12 disciplines that are a part of the TOPS scheme that is being run by the Ministry of Youth Affairs and Sports, okay, under the Mission Olympic Cell, right? We understood yesterday what is the Mission Olympic Cell, what is the National Sports Development Fund. We did all of that. If you have any particular doubts, head over to yesterday's discussion, okay, the 6th of September. Very, very important insofar as the sporting support given by the government to say the sporting industry is concerned. Very, very important. So which of the above are not included now? The sports that are included under the top scheme are the high priority sports, okay, wherein you do not find, say, the infrastructure or the bottom up approach of the growth that is required, that is unavailable in those particular sports. So you're looking at, say, sports like archery, okay, or golf, all of these sports, kabaddi. Kabaddi, in fact, is again not in the top scheme, but you find that all of these sports, say javelin, are included in the top scheme, okay, whereas basketball, football, volleyball, Malakhamb, these are not a part of the top scheme. Similarly, cricket is also not a part of the top scheme so far. Correct? Parcham, good morning. Ashlekha, good morning. Parcham, welcome, welcome. You're most welcome. Okay. So all of the above are not included. Let's look at statement C, question C. Asian Games coming up very soon in 2023, going to be held in Hangzhou, China. Okay. We are sending a cricket team, by the way. Let me know who's the captain of the cricket team. All right, he's a very powerful batsman, okay, plays for the Chennai Super Kings, I believe. So go ahead, let me know who's the captain of the cricket team that is going to represent India at the Asian Games, right? Cricket is a part of the Asian Games 2023, and surprisingly, India has never won a medal. In fact, the reigning champions, the reigning medal holders are Sri Lanka for the men's and Pakistan for the women, right? So the correct statements here being all again. Okay, Sowa Rigpa, we discussed integrative medicine, traditional medicine, TCIM, right? Your neighbor, you're correct. Rituraj Gaikwad. Okay. Sowa Rigpa is not from Tamil Nadu, by the way. Okay. Sowa Rigpa is from the mythical, the ancient land of Tibet, and it uses pulse analysis and urine analysis to diagnose and recommend treatments. Okay. So the correct statements here being only B. Now, insofar as the health systems are concerned, I would say that go ahead, look at the Ministry of Ayush's website. I had told this to you yesterday also. Yes, it's a plethora of information, and especially now that the WHO summit on traditional medicine was held in Jamnagar, okay, Gujarat, I think it's only befitting that you go ahead and apprise yourself of each and every form of say the traditional medicine architecture in India is concerned, say Siddha, Unani, Ayurved, all should be on your fingertips, right? Let's look at the next question that I had for you. So these institutes, Ayurved, Homeopathy, Unani and Siddha, well, they are located as they are mentioned. Ayurveda is in Jaipur, Homeopathy in Kolkata, Unani in Bengaluru and Siddha in Chennai. All are again correctly matched. And finally, the last question that I have for you, which I was a little surprised to see that many of you got incorrect, okay, because this is a basic geography question. And the most of the, say, confusion came out of statement D, Strait of Dardanelles. So here is the figure for you guys, okay. Now what I want you to figure out is, and just focus here for a second, you are looking at two straits here. This one is the Straits of Dardanelles, which connects, say, Aegean Sea to the Sea of Marmara, which is eventually, the Sea of Marmara is connected to the Black Sea by the Bosphorus Strait, okay. So you can say that yes, Dardanelles does connect the Mediterranean to the Black Sea via the Bosphorus Strait, right? It does not provide, say, a continuous, continuous passage, but it is one of the choke points. It is one of the important choke points insofar as connecting from Mediterranean to the Black Sea is concerned, okay. So you're looking at two straits there, Strait of Dardanelles and Strait of Bosphorus. Whereas the Kerch Strait is which separates the Black Sea from the Sea of Azov, right? So Black Sea is a marginal sea, true. River Volga, Danube and Dnieper drain into the Black Sea. Unfortunately, no. Okay. Volga does not drain here. Danube and Dnieper do. Kerch Strait separates Black Sea from the Sea of Azov, correct. Dardanelles Sea connects Black Sea to the Mediterranean Sea. Well, yes, indirectly, yes, it does, which means your correct statements here are A, C and D, right? Okay. Make a note of this particular strait, please. This is the Strait of Bosphorus that I just pointed at, okay? This particular area, right? So these are my individuals who have taken the effort to go ahead and answer the questions. You might have got one or two incorrect, that's inconsequential. What is important is that you are now learning. You are learning your mistakes and you are learning where you are going wrong, which means you will not repeat those mistakes. Okay. So Ashlekha, Pranjul, Crystal, Tanu, Laughter, Koda, Mandeep, Pooja, Lekam, Karuna, Hani, Aditya, Ronnie, Akshay, Abhishek, Shashank, Simran, Raghavendra and Frown Clown. Thank you so much, guys. Okay. Some of the answers are from in the comment box that they are left for me. Some are sent to me on the email. I would request all of you though, put it in the comment box on YouTube so that it's easier for me to collate. Okay. To the rest, the topics that I have for you today, El Nino, La Nina, very, very important. And the questions that can come out of there are, say, n number of possibilities. Okay. The ways I as an educator can go ahead and say confuse you via questions are many, which means you need to pay attention right now as we begin this discussion. Okay? Pranjul, good morning, let's go. Okay, let's get started. Chaliye. So why are we discussing Walker cell and El Nino first? Well, a recent study has raised concerns about the impact of human activities. You're looking at anthropological causes that can now go ahead and say change the entire behavior of the Walker cell circulation and thereby say El Nino or La Nina or whichever way you're looking at it. Okay. Eventually, it's the Walker cell and its behavior which determines whether you have say El Nino or La Nina. Okay. So a recent scientist study says, well, you and I could be changing that. We'll understand how. Okay. So it has found that Walker circulation has changed its behavior since the industrial era, which means you're looking at say the emissions of GHGs, which becomes the critical factor here. And multi-year El Nino and La Nina events could become more frequent. Okay. Which means either ways, you're looking at these global say communications, global atmospheric communications that will now be aggravated, which means you are going to have weather patterns that will change across the globe. Okay, that's the whole point of atmospheric communications, right? So findings have revealed that the transition from El Nino to La Nina has slightly slowed over time, which means you're looking at say more droughts, more fires. Okay, let's understand what El Nino is, let's understand what La Nina is, and this shall make sense to you. Okay, let's go. Let's get into the discussion. Here is the map. Now I want you to pay attention. Okay, guys. Jerin, welcome. Good morning, guys. Pay attention now. So in terms of a normal year, okay, let's discuss a normal year first. What are you expected to observe in a normal year? Now, ideally, for example, if this is briefly say my equator, right? I'm talking about the Pacific right now. Only the Pacific is what we will focus on. Okay, let's understand it in the simplest manner because the books will kind of confuse you. So now what is observed is, ideally, in a normal year, you find that because of the trade winds on both sides of the equator, right, you have this movement of ocean water that takes place from the coast of South America to the coast of Australia. Okay. Now, obviously, common sense would tell you that because these trade winds are, say, warm winds, right, they are near the equator, so they are going to push this water, and eventually what you find is that a creation of a Western Pacific pool is observed here. Western Pacific pool, again, an accumulation of a large volume of hot water. Understand it, simple basics, okay? You are not going to become Alfred Wegener in an overnight discussion. The point is to understand the discussion, okay? So here you have, say, Western Pacific pool now that has gone and accumulated. Which means what? Eventually, you are expected to find, say, low pressure here, correct? That it is going to, say, influence local weather conditions, which means, again, you have low pressure over Australia. Now, once you have low pressure, which means your air from Australia starts rising. Okay, variation in density so happens. After that, condensation follows. Yes, because again the air mass is losing, say, density. Yes, it is again variation in density is happening. Normal lapse rate is being observed, 6.5 degrees centigrade per kilometer. So eventually you have cloud formation just above Australia, and thereafter rainfall shall follow. Okay, good, rainfall has followed, good for Australia so far. Eventually what happens? This dry air mass from Australia now has to descend somewhere, and this is where it descends. Southern America. A descending air, my students, you know, is a place of high pressure. Correct? Which means what? Eventually we have completed this circulation, right? You have low pressure there, high pressure here. The cold, dry wind has now gone ahead and dived right over Southern America, which means once again this cyclical process so begins, because again air moves from high pressure to low pressure, right? Essentially this is what a Walker cell is. This circulation that you see, okay, between Southern America and, say, Australia is Walker cell. What are the key determinants of Walker cell? Well, common sense will tell you, number one, you need strong trade winds, don't you? Because until and unless you don't have strong trade winds, you're not going to be able to move your Western Pacific pool here. Now, after that you have understood this, after you have understood that particular concept, please understand now that all the water has gone from here to Australia. What happens here then? What's the story here? Well, the story here is pretty simple. Okay, what you find is that eventually, because of accumulation of hot water here, you have upwelling of cold water here. This resource-rich, nutrient-rich water that comes from deep within the ocean surfaces near the Southern American coast, okay, which is why again you find, say, that you have deserts that you find here. Yes, it sucks out the entire moisture from the place. Because of this upwelling, again the phytoplanktons follow, the fishes follow, you have the guano industry, the fertilizer that comes out of the feces of the bird, yes, all dependent on, say, this particular process. So that essentially in a nutshell is Walker circulation. Correct, guys? Yes. Now what has been observed? This is again a normal year I'm talking about. Now once you understand a normal year, you have essentially understood La Nina. Okay. Because after this, the story after this is quite simple. The moment you have low pressure over Australia, one arm of this cold air which has dived towards Southern America, the second arm is also going to dive somewhere. Yes. What you find is that eventually this second arm dives here. The Mascarene High, a very, very important island insofar as the outcome of monsoon over India is concerned. Okay. The Mascarene High. The Mascarene Islands, okay, the high pressure that is conducted there, low pressure, cold air diving towards the Mascarene High. Now you know that air from high pressure rushes out. It wants to go and find an area of low pressure, which is what this high pressure area at Mascarene also does. It rushes out and heads towards Horn of Africa. Okay, crosses the equator, Coriolis force acts on it, and thereby it is now turned towards India, okay, headed India as the monsoons. Now, if this is how the Walker cell circulation eventually is going to determine my Indian monsoon conditions, okay, La Nina, wherein all of these conditions, the normal conditions, okay, for example, the best way to understand La Nina, if this particular model, which we began right from, say, the trade winds, the hot air, okay, the rainfall happening, Southern America seeing upwelling, the masculine high getting stronger, the rainfall, say, over Australia, all of that, eventually our Indian monsoon getting better. If in a normal year, if it functions, say, at 100% efficiency, okay, in a La Nina year, now let's discuss La Nina very quickly. In a La Nina year, what you find is that it functions at, say, 150% efficiency, okay, a crude way of understanding it, right? So what you're expecting again, in a La Nina year, okay, you have the trade winds that are way, way, way stronger, extremely strong, which means your Western Pacific pool here is stronger than before, which means your low pressure here is stronger than before, which means your rainfall here, which happens because of the vertical movement of the warm air that loses heat due to lapse rate, eventually condenses, forms clouds, rainfall, that is again happening at a much stronger rate. Similarly, the cold wind that goes from here to Southern America and the cold wind that goes to Mascarene, both again better in shape, better in, say, efficiency. Eventually, the air that rushes out from here and then finally diverts towards India, which means better monsoons for us. La Nina is essentially the normal conditions working at 150% efficiency. Correct? Now, if this means essentially that my monsoons here are benefiting, okay, now let's understand El Nino in the simplest manner. El Nino is essentially to do with the La Nina conditions for going absolutely behind. If normal conditions were 100% efficiency, El Nino, you are going to go and reduce the whole efficiency bit now. Okay. So what is expected in El Nino? Eventually what you're looking at is that the mascarene high that is key to my Indian monsoon, well, that is reduced considerably. And why does that happen? Because what you find is that unlike, say, low pressure that was observed in normal or La Nina conditions over Australia, you find that in El Nino, you have high pressure here. And in Southern America, you have low pressure here. How could that have happened? You might ask me. Well, that happens because the primary condition, my strong trade winds, they are no more strong now. They are weak, which means my Western Pacific pool that would have ideally formed here has not formed anymore, or has formed but is considerably weakened. In that case, now it's easy to understand what has happened. You will see that the entire story starts from here again. Rainfall over Southern America. You have one arm falling here, okay, which means no rainfall here because descending area, no rainfall, okay, no rainfall in high pressure, which means your mascarene high, which was, say, functioning at 100% efficiency during normal conditions, is now functioning at 50% efficiency. Which means your Indian monsoons, which were working at, say, 100% efficiency in normal conditions, are now working at 50% efficiency, which means what? It's bad for our monsoons. Okay. Straight away, your agricultural output is compromised. Okay. Your whole economics of the country is compromised. Why? Because the trade winds here in the Pacific Ocean decided to act up. And that essentially, in a nutshell, my friends, is El Nino. Now, there's one more understanding of it. Sometimes you might have heard of the word ENSO, El Nino Southern Oscillation. Okay, another very easy concept to understand. Let's understand and do it in 5 minutes. Okay, here only I'll do it for you. So in ENSO, oscillation is essentially to do with what? A pendulum-like movement. Is that not oscillation? Correct. That is what the primary gist of ENSO also is. Okay. What in ENSO you do is that there are two ports. Okay. Say in Eastern Hemisphere and Western Hemisphere, you are going to go ahead and say look at the differences, the variabilities that are so arising on the ocean water. One port over Australia, Darwin, the other port in the Eastern Hemisphere, Tahiti, okay, part of Polynesia, what you do is go ahead and measure the difference. Why? Because eventually the basics of geography, that things move from high pressure to low pressure, right? So if your whole movement of trade winds is moving this way, which means Tahiti will see high pressure and Darwin will see low pressure. Now in a normal year, this would be expected. For example, say I had 100 bars here and say 50 bars here, normal year. In an El Nino year, I have told you this will work at 150% efficiency, which means what? In an El Nino year, for example, now this figure goes up to say 150. My Darwin, my low pressure becomes even lower, which means it becomes say 30. Similarly, this is an La Nina year. Similarly, in an El Nino year, now I have told you, it goes and reduces its efficiency drastically, which means if normal conditions you expected 100 bar over Tahiti, now you are expecting say 80 bar. And your low pressure is now not that low anymore, which means you expect say around 60 bar here. Now essentially, SO is to do with the difference of these two values. Okay, where is your difference the lowest? During El Nino, your difference is only 20. Whereas during La Nina, you see your difference is 120. Whereas in a normal year, your difference is 50. Do you understand now? A lower oscillation means El Nino. A lower oscillation is bad for monsoons over India. That is essentially the gist of southern oscillations. If you have higher oscillations, it means that you're expecting La Nina to happen now. If you have lower oscillations, it means that the differences, the variabilities between Darwin and Tahiti, they are not that much. Okay, the pressure that should have been strong to drive the entire WPP, the Western Pacific Pool, is not there anymore. Which is why, again, the high pressure, low pressure and masculine high becomes my point of focus. Right? If you understood El Nino, La Nina, and say ENSO, and we did it in what? 20 odd minutes, 30 odd minutes. If you understood it, leave me a like. And even if you don't want to leave me a like right now, don't worry. Right now, I'll also explain Modoki to you. Buy one, get one free. After that, leave me a like. Alright? Here, let's understand Modoki in the simplest terms. Modoki is a Japanese term which essentially means middle. Beach mein. Okay? So this entire Western Pacific Pool, okay, because of trade winds, the Western Pacific Pool that eventually determines low pressure over Australia, that is observed to just go and lodge itself in the middle of the Pacific Ocean. Middle. Modoki. The Western Pacific Pool, the warm water, is right bang in the middle of Pacific Ocean. Which means what? Your low pressure is here, my friends. If your low pressure is here, which means your HP will be here, obviously. Diving air will be here. The same concept again. Now, if your HP is here, which means again, your high pressure, the masculine high here is going to be lower, which means again, your monsoon here is going to be lower. That is El Nino Modoki. The rest of the theory you know. The latent heat and the condensation, the rainfall, the diving arm, the falling arm. I assume you understand that after following the first discussion. Okay. So now the interpretation of this. If all the rainfall, because let's understand, if the low pressure is over in the middle of the Pacific Ocean, which means my air is rising, clouds getting formed, rainfall happening. If all the rainfall is getting lost here, okay, is it good for Southern America or bad for Australia? You will see it is both. Why? Because in any case, in a normal condition, you had high pressure over Southern America, which means rainfall anyways here was not expected. So in case of a Modoki, nothing changes for them. Rainfall anywhere here is not expected. Fine, they are happy with that, which is why the deserts here are fine. But in Australia's case, in a normal year, you had expected low pressure here, which means rainfall here. But in a Modoki year, you find suddenly no more rainfall here. Why? Because high pressure. That is the interpretation of it. Similarly, your homework now, before I close and go to my second topic for the day, your homework is to figure out the circulation for La Nina Modoki. Okay. Again, apply the same concept. The same concepts should be applied. Start with the location of the Western Pacific Pool. Right? And in terms of the examination, here is the tip for you, right? So you will see many videos, many explainer videos, 90 minutes, 2 hours long. What you essentially need to do, my friends, is to figure out where your low pressure is getting formed, which can only be ascertained by the location of the Western Pacific Pool. So if ever in doubt, start with the Western Pacific Pool. Where is it getting formed, which will eventually determine where your low pressure is, which will eventually, the whole story is to understand the story at masculine high. If the pressure is high here, right, if you're experiencing high pressure here, the straight away interpretation should be that my monsoons are going to be bumper. In fact, in a La Nina year, you will find that the masculine high, which is functioning at say 150% efficiency, you are looking at not just extensive rainfalls here, but the chances of flooding also. Okay. So that is the whole point. Get the status of masculine high, you understand the status of Indian monsoons. ठीक है? All right. Okay, that's your homework, guys. Do let me know in the chat box below if you want to go ahead and answer this for me. So in La Nina Modoki, okay, firstly tell me where your Western Pacific Pool is getting formed. Over Australia, are you going to experience low pressure or high pressure? Over Southern America, are you going to experience low pressure or high pressure? And whether your masculine high is getting weakened or is it getting stronger? That's all I expect from you in the comment box. Let me know. I'll be happy to see multiple answers for this because this is an extremely easy concept which has been over complexed. It has been unnecessarily made very difficult by many books. I don't understand the point of it. Okay. All right. Let's look at this question, guys. Let's do this. Which of the above may positively influence Indian monsoons? Whenever in doubt, go to the map. Okay. El Nino, La Nina, positive Indian Ocean dipole. Okay, Indian Ocean dipole we didn't discuss, but fine. Indian Ocean dipole is essentially to do with, well, a positive Indian Ocean dipole essentially means your Arabian Sea temperature is higher than your Bay of Bengal Sea. Okay. Now, if you understand geography, if you have done your physical geography NCERT standard 11th, you will know that the temperature of the sea surface water, if it is increased, the chances of tropical cyclones are high. Okay. Which means again, it has a bearing on the monsoons also. So there it is. I've given you a hint. Let me know the answer to this. Negative IOD, which means the converse is true. Okay. Strong Walker cell, will it help my Indian monsoon or will it weaken my Indian monsoon? Weak Walker cell, once again, will it help my Indian monsoon or weaken my Indian monsoon? Okay. And El Nino Modoki, does it help Indian monsoons or weaken Indian monsoons? You will let me know your answers in the comment box below. Right? Okay. Let's move forward. But let me get this sorted first. Great. Let's go. So you identify the correct statements here now, guys. The index of oscillation. Remember the story between Darwin and Tahiti. The lower the difference, okay, the smaller your index, which means it's El Nino. True or false? Let me know in the chat box. If the difference between the pressures of Darwin and Tahiti is less, is it good for Indian monsoon or not? Let me know. Because essentially that's what a smaller index of oscillation is. Okay. So, low index of oscillation in the Pacific Ocean benefits Indian monsoon. High index of oscillation in the Pacific Ocean benefits Southern America. And by benefits, I mean, well, you expect dryness in Southern America. So, if you get rainfall there, that's not benefiting, by the way. Benefiting is status quo should be maintained. Right. So, let me know the correct statements here. Question C, Enzo. Easy. The same question to do with, say, your index difference. So, ENSO are large pressure differences between tropical oceans of eastern and western hemispheres. ENSO are low pressure differences between tropical oceans of northern and southern hemispheres. Here's a hint for you if you're getting confused. Remember, Southern America, Australia. We went ahead and discussed Darwin and Tahiti, which means we went ahead and discussed Eastern and Western Hemisphere. So there it is. I have given you a hint here. Okay. Figure out the equational difference that we did. In a normal year, what is going to be expected? In an El Nino year, what is going to be expected? In a La Nina year, what is going to be expected? figure out the difference, gives you your index of oscillation. समझ गए आप? You shall never get confused in these simple topics anymore, please. Right? Okay. Next question. Okay. Identify the incorrect statements. El Nino, Modoki. Does it see much change in rainfall patterns over Southern America? Okay. I gave you the answer to this in this discussion. If you still have doubts, just go rewind 5 minutes. You'll understand the answer. And El Nino Modoki results in reduced rainfall over Australia and India. Identify the incorrect statements. Okay. Remember the Modoki essentially is what? Here is your Australia, here is your Southern America, here is your Western Pacific pool, here is your low pressure. Go ahead, draw the figure, figure out. बारिश कहाँ हो रहा है? बरखा, बिजली कहाँ हो रहा है? Figure that out. Alekha, good morning, welcome. All right, so that was the introductory lecture to El Nino, La Nina, Modoki, ENSO, all of that we did in 37 odd minutes. Okay. Now, if you understand this, and if this is the way you want to connect with us, because, well, what I gave you is a trailer, okay? The whole class for this is a lot more exhaustive, okay? Go ahead, sign up for a Prelims to Interview program. You will find that we do a lot of in-depth discussion, a lot of application-based understanding, and not just the bookish knowledge. Eventually, you should understand the applications in real life of each of these geographical phenomena. Where are wildfires going to happen? What is the consequence of El Nino Modoki and El Nino on, say, Indian agriculture and Indian economy? Okay. How does it go ahead and, say, affect our small farmers? All of that is the larger part of the discussion that could be carried forward after having understood El Nino, La Nina, and, say, Modoki and the various oscillation systems. Okay. So if that is of interest to you, and obviously if you're not doing it in that particular manner, I suggest that you consider joining us for the Prelims to Interview program. 11th of September, 8 a.m. is the next batch starting. Okay. I am associated with the English team. However, this course is being offered in what? 3 languages. Bilingual, English and Hindi. Okay. I am with the English team, and my areas of expertise or interest, as you may consider, are environment, geography, IR, current affairs, and obviously CSAT. Okay. Many of you have been associated with me in the CSAT program. So go ahead. For those of you who are still on what do you call it? Humpty Dumpty wala scene mein ho abhi ki kis side jana hai. Go ahead, take a call fast and go head over to studyiq.com, okay? Or you can find the sign up link in the description box below. Use the code BALIVE. Why? Firstly, this is of benefit to you, immense benefit to you. At the same time, secondly, I become a part of your journey, okay? And so we understand and we dissect concepts like what we did today with El Nino, La Nina, Modoki, ENSO, Indian Ocean Dipole, okay? There's one more concept that I should have explained here, the Madden-Julian oscillation, okay? All of these are done thoroughly in our Prelims to Interview program, not just from the Prelims perspective, the mains perspective more importantly. Okay, so do consider signing up for this. I hope to see many of you in this program. Now look at this troubling news that I have for you guys. Okay, Odisha records over 61,000 lightning strikes within 2 hours. 2 hours, 61,000 lightning strikes. Okay, Odisha witnessed a staggering 61,000 lightning strikes, leaving residents obviously in a state of shock and distress. Now let's understand what is lightning first. Then I'll tell you the exact points that you need to know for this. Okay. Lightning, a powerful and visible electrical phenomenon that takes place when there is a buildup of electrical charge. Essentially, if you understand geography, you should understand the concept of stability. Okay. That's a elements in our atmosphere, elements in the oceans, elements in our lithosphere, all of them seek stability. Okay. And more so when it comes to, say, electrical charges. They seek stability straight away. How do they get stability? By grounding themselves. By making sure that they have released all the energy that lies within them. Okay. That is essentially the crux of lightning. So let's understand that one by one. The discharge of this energy. So you have clouds. I'll tell you what is there in clouds, but eventually for the timing, understand that they have energy here. So this energy is to be discharged, which means let out. Okay. And how is that going to happen? We'll discuss. But eventually the thunder you hear is due to expansion of air. The release of air quickly from the clouds. Okay. Trapped air within the clouds when it is released quickly. Okay. So that is to do with thunder. So we'll understand that both right now. But from the MCQ perspective, please make a note of these 2 points. Firstly, we are among the 5 countries to have an early warning system for lightning, which can essentially give you a period of say 3 to 5 hours, okay, based on the local wind circulation, local air circulation, okay, local conditions that are building up. A possible say 3 to 5 hour window can be provided. However, it is not categorized as a natural disaster in India. Why? Because the government is of the opinion that it is an avoidable disaster. It is an avoidable scenario. Okay, that most of the problems that so arise because of lightning strikes come because of lack of awareness. Okay, Karuna, good morning, welcome guys. Okay, so let's understand how lightning happens now. See this? I've got this image from the internet. Now what I want you to focus here on is this particular area, and thereafter this particular area. Okay, this is what I want you to focus on. Now, what is lightning exactly? Like I told you, you have clouds that have energy between them. But the question so arises, how do clouds have energy? Okay, so let's understand the components of clouds first. Now, clouds normally have say water. Okay, and because again they are rising up, you also find that they condense into say ice crystals. Okay, so this is common sense, fine. They are going up, they are condensing, forming ice crystals. How does that still give me energy? Does not explain that. What you find is that they are colliding between each other. Okay, as this process is happening, they are also colliding between each other, and hence a kind of a charge is being released. Eventually what you find is that a particular cloud will have say positive areas of charge, negative areas of charge. Let's name this cloud say cloud A, right? Similarly, let's name another cloud, cloud B. This will also have a positive area of charge and a negative area of charge. My ground, my friends, is to be considered as positive, right? So now what is to be observed? Eventually you also have air that is trapped within the cloud. Now, as this collision between say water and ice crystals is happening, okay, and this charge that is getting created, eventually this charge starts to increase, right? This is now increasing exponentially. Okay. Now, the key point that I told you, systems seek stability. Everyone wants stability in life, including you guys, right? So here what happens? How do they go ahead and seek stability? They can do so in 3 manners. Number 1, that these charges within a cloud, which means intra-cloud, go ahead and interact with each other. Or you go ahead and A interacts with B, which means inter-cloud. Or you look at one cloud and the ground, because let's not forget that the ground also has positive charge. So you have cloud to ground interaction. What did I do? One second. Go back. Just a sec, guys. Where do I go? Where do I go? Where do I go? Home. I'm not sure how to go back, PC. Thank God, we are back. Okay. Right. So you have intra-cloud, inter-cloud, and cloud to ground. Okay. So essentially what you find is that if this distance is close enough, you find that cloud A goes ahead and seeks stability by interacting with the charge of the ground. At the same time, A and B together can go ahead and interact. The cations and the anions can go ahead and interact within themselves and release energy. Okay. And these two together can also merge together and then form and seek stability with the ground. So these are your three types of, say, conditions in which lightning can be formed. Okay. Now let's understand the process very simply, in the simplest of manner. Let's look at this. Essentially, the intra-cloud flashes. You see these charges seeking to go ahead and interact with each other. At the same time, you are going to have this particular cloud A seeking stability by interacting with the positive of the ground. Or you can have another cloud B with the same conditions, positive, negative, which can interact together. Now, how is the thunder released then? What's the sound about, you might ask me. Remember this trapped air that we just discussed here? This trapped air. Well, eventually when this is released, okay, you find that it's thunder that eventually that you hear, you know. So go ahead, answer one simple question for me. So for example, why is it that you go ahead and see a lightning before you hear it? Or sorry, why is it that you see a lightning before you hear it? Let me know the answers in the chat box. Okay, what could be the reason? Right? Let's look at the notes that I have for you, my dear friends. So this is essentially what you're looking at. An inter-cloud strike, or you're looking at a cloud to ground strike, or you're looking at a discharge within the cloud. These are the three possibilities in which you have lightning getting formed, which means in Odisha, this particular, say, 61,000 lightnings in, say, 2, 3, 4, 5 hours, whatever the time that is mentioned, you find that a lot of interaction is happening within the clouds and between the clouds and, say, among the larger realm of the clouds and the land. So now what does common sense tell you? Yeah, with, say, climate change, do you expect more of lightning to happen or lesser of lightning to happen? In India's case, for example, if I were to just give you a small statistic, most of the lightning in India's case is observed, say, in Northeast India. Okay, you're looking at West Bengal and Sikkim. Obviously, why? Because you're looking at, say, the monsoonal intensity that is much higher in Northeastern India. For reasons, again, that is to do with Indian monsoon. You have the merging of the two branches there. Yes. So this is where you find the maximum number of lightnings. But the fatalities are not the maximum in these states. Okay. The fatalities, in fact, are highest in Madhya Pradesh, in Maharashtra, and in Chhattisgarh. This is where the fatalities are. Right? So what does that tell you? That yes, even though, say, the number is higher in these states, yes, it does point to, say, an awareness issue, a behavioral issue, right? Which is why you find that awareness and information dissemination is key so far as to avoiding fatalities regarding lightning is concerned, right? So just going ahead, and so are you at risk, for example? For example, here is a common, say, misconception. So you are here, this is you, okay? This is you here on the road, walking. Huh? Now it is raining, it's cloudy. Now a lightning strikes the ground. Are you completely safe? No, my friend, you're not completely safe. Why? Because if the ground is wet, or if it is little matty, what you find is that all of this energy that has now henceforth been released into the ground, if it is again a cloud to ground interaction, because of the water presence here, or at least moisture content being high here, that you are also at risk of electrocution. Okay. So it's not just that you go ahead and avoid, say, the weaker areas, that you go and stand near a tree or you're walking in a forested area under a monsoonal cloud. None of that. Even if you are, say, walking on a relatively wet surface, you're still at a considerable threat of getting electrocuted. Okay? Correct. Bhagyashri Pranjul. Correct, Karuna. Good, good. That was a simple question anyways. Okay, good. But yeah. So go through these notes that I've given you. Meanwhile, let me know one thing. Okay? Let me know one thing also, if you are going to answer this in the comment box, go ahead and answer me this. That obviously, say, most kind of lightnings, okay, are observed, say, from up to down, normally. Okay. Name me a particular type of lightning that goes from down to up. Okay. I'll give you a hint, that is observed in the stratosphere. Alright, you will let me know this too. So normally the direction of a lightning would be say from a higher elevation to a lower elevation, okay, from say up to down. But then there is a certain type of lightning that just goes the opposite way. What is the name of it? You will let me know. I've given you a hint, it is found in the stratosphere. Right? PYQ 2013. Go ahead, my dear students, answer this for me in the comment box below. During a thunderstorm, the thunder in the skies, cloud, positive, negative, the trapped air. Okay? So the thunder in the skies is produced by what? The meeting of cumulonimbus clouds in the sky, lightning that separates the nimbus clouds, violent upward movement of air and water particles, or none of the above. You will let me know your answers in the chat, in the comment box. Whereas question number F, if a lightning is categorized as a natural disaster, so I have told you that lightning in India, not a natural disaster. No. Okay. So if lightning is categorized as a natural disaster, victims can get compensation from which relief fund? Is it the state disaster relief fund, the national disaster relief fund, the PM cares, or say PM, the different funds that are available? Which fund the compensation comes out of? You will let me know. In India, lightning is maximum in the northeastern states, West Bengal and Sikkim. We just discussed it. And in India, lightning fatalities are maximum in Madhya Pradesh, Maharashtra and Chhattisgarh. Identify the correct statements. Right. If you have any particular doubts, by the way, students, we have discussed, say, La Nino, El Nina, Enso, Modoki, and obviously, it's a little tricky to understand in the first time. So if you have any particular specific doubts that you are unable to go ahead and resolve for yourself, here is where you go ahead and connect with me, okay? My Instagram handle is this. Scan this, or if you have a particular big doubt, you want to go ahead and give me a whole passage of questions that you have for me, this is where you send your questions. Okay? Right, the last topic for the day now. See this tweet, guys, historic tweet. Okay, let's look at the key components of the tweet one by one. Right? 1 second, I'm unable to see your chats. I hope it is working. Okay. Is the chat working? Just let me know. Just type yes very quickly in the chat. I'm not sure. It's not moving much. Okay. Let's look at Anaglyph and ISRO. Okay. Yesterday, Indian Space Research Organization put out a tweet. Let's look at the tweet. Chandrayaan 3 mission. Anaglyph, a simple visualization of the object or terrain in 3D from stereo or multi-view images. Now, what you see is, do you see these colors that you see here? You see red here. Okay. This particular photo that has been released by ISRO, just look at it carefully. You see red here. You see a certain tinge of green here. You see again red here. You see green here, red here, green here. So how is that happened? Okay. Thanks, guys. Thanks for letting me know. My whole thing had just started hanging. Thank you. Okay. So do you see this? Do you see this tinge that you see? Red, green. How is that possible? Okay. So what ISRO has done is gone ahead and merged two photos. Okay. Let's look at it. And that process is called anaglyph. Anaglyph is essentially a simple visualization of an object or a terrain in 3-dimensional. Okay. So this photo that you see here, you find that stereo images were taken by ISRO. Okay. So what does stereo image essentially mean? If this photo, okay, if you were to go ahead and say use red glasses, okay, glasses with red filter, no? If you use and watch this photo, see this photo with a glass of red filter over your eyes, okay, what you are going to observe is that the image will look 3-dimensional. So here is your left eye, here is your right eye. If you have to go ahead and observe this photo, right, with a red filter over the left eye, so here you have a red filter and here you have a cyan filter, this photo essentially is going to look 3-dimensional to you. And this is the whole process of anaglyph. Okay, you find that this image was captured by the NavCam stereo imager. The NavCam stereo imager is, the regular watchers will straight away tell me, is on the lander or the rover? It's on Pragyan. Okay. So this photo was taken from the Pragyan, and what you find is that it has used this particular methodology, anaglyph, okay, wherein you are going to merge two particular types of photos and can be best observed by using filters over your eyes so as to produce a three-dimensional effect of the photo. Very, very important concept, especially why? Because it introduces a new term to you. Okay, so the anaglyph presented here once again, created using navcam, which was on Pragyan. Okay, in this 3-channel image, the left image is positioned in the red channel, right image is positioned in the blue and green channel, which creates cyan color. Thus, the difference in perspective gives us the stereo effect, which means to best observe this photo, if you go ahead and use this method, yes, you will actually see the moon's lunar surface in 3 dimension. That is essentially the process of anaglyph. Very, very, very important. Okay, go ahead and have a look at this photo. I will be sharing this in my Telegram channel at noon too. Right, my dear friends, ladies and gentlemen, that concludes today's class. We have discussed very, very important topics. Okay, El Nino, La Nina, Mudoki, ENSO. Well, MGO is left, but we'll do it some other day. Okay, we also looked at our anaglyph, and we also looked at lightning. Okay, important concepts, and as you will see, if you have been going through your PYQs, your previous year's questions, you will find that questions frequently get asked from here. So it is best recommended that go ahead, revisit the whole lecture if you have any doubts. Reach out to me if you are say still unable to resolve your doubts, and I'll be more than happy to help you out. Meanwhile, if you understood the 3 topics of today, I will once again request you to please consider leaving me a like and sharing it with your friends if they would also like to seek help regarding understanding El Nino, La Nina. Quick revision in 20 minutes. Okay? Thank you so much for your time and patience, guys. And I hope to see all of you once again tomorrow morning, 6:30 a.m. on StudyIQ IAS, as we'll seek to understand another set of important topics and not just articles, because, well, articles get you nowhere. Topics too. Thanks for watching. Till I see you tomorrow morning.